So in this video we are going to discuss trigonometric ratios up to transformations, example 2. So in the example 2 second bit, if A, B, C are angles of a triangle, then prove that cos 2A plus cos 2B minus cos 2C is equal to 1 minus 4 sin A sin B cos C. So now in the solution given that A, B, C are angles of a triangle, A, B, C are angles of a triangle, we know that the sum of the angles is equal to 180 degrees. Or angles of a triangle, we know that the sum of the angles is equal to 180 degrees. So that's why A plus B plus C is equal to pi. Now what is given LHS here? So the LHS is left hand side cos 2A plus cos 2B minus cos 2C. So which is we have to prove that 1 minus 4 sin A sin B cos C. Now here first two terms if you observe here, so which are like cos C plus cos D. So we have the formula for cos C plus cos D is equal to cos C plus cos D is equal to, so 2 cos C plus D by 2, 2 cos C plus D by 2 into cos C minus D by 2 we have. So now here which is replaced by, so 2 cos, so 2A plus 2B, if you apply the formula for first two terms, so this is cos of 2A minus 2B by 2 and minus cos 2C here. So now here, if you take the 2 common in the numerator in the both the terms, we get 2 gets cancelled. So now 2 cos of A plus B into cos of A minus B and minus cos 2C we have. See here, we know that A plus B plus C is equal to pi. So from this A plus B is equal to pi minus C. Now this A plus B is also replaced by cos of pi minus C into cos of A minus B and minus cos 2C. Now cos 180 minus theta, we have the cos 180 minus theta. So cos 180 minus theta is equal to always minus cos theta, which is belongs to the second quadrant. In the second quadrant cos is negative. So that's why 2 into this is minus cos C into cos of A minus B and minus cos 2C this is. So now here, so 2 into minus cos C is nothing but minus 2 cos C, so which is equal to minus 2 cos C into cos of A minus B and minus cos 2C we have. See here, we have 2 cos C and there cos 2C. Cos 2C also should write in terms of so cos C. So now we have to apply that. Here cos 2 theta is equal to, we have 2 cos square theta minus 1. We have the formula 2 cos square theta minus 1. So which is equal to minus 2 cos C into cos of A minus B and minus, here writing 2 cos square C minus 1. So here minus 2 cos C into cos of A minus B and here minus 2 cos square C if you multiply with minus, and here minus into minus is plus 1. Now if you observe in both the terms, clearly we have minus 2 cos C is common. So when you take out minus 2 cos C is common here, so this is cos A minus B and here already taken minus 2 cos C common. So that's why 1 plus cos C is left over here and plus 1. If you multiply this is with minus 2 cos C, this is remains same. Minus 2 cos C into cos A minus B and minus into plus C is minus 2 cos C into cos C, that is minus 2 cos square C. So but here we know that, so C is equal to here, C is equal to, we have pi minus A minus B is nothing but pi minus of A plus B. Now here also, so minus 2 cos C writing as it is. Now this is cos of A minus B and plus here this cos C is replaced by pi minus of A plus B. Why? Because A plus B plus C is equal to, we have a pi, so that's why, so C is equal to pi minus of A plus B. When you replace C is equal to pi minus of A plus B, it is just like, so cos of pi minus theta, so which is nothing but minus cos theta. We know that already, we applied here also the same property. So now which is equal to minus 2 cos C into here cos of A minus B, and plus this is cos 180 minus of A plus B is nothing but, so minus cos of A plus B, this is minus cos of A plus B, and plus 1 is as it is. Now which is equal to here minus 2 cos C into cos of A minus B, and here plus into minus is minus cos of A plus B, and here plus 1 is as it is. Now if you observe that, so this cos A minus B minus cos A plus B, inside the bracket we have one of the standard formula, that is cos A minus B minus cos A plus B is equal to, we have 2 sin A sin B, 2 sin A sin B. So now that is replaced by 2 sin A sin B, within the bracket we can write that as per this formula. So 2 sin A sin B, and at last plus 1 is as it is. So now if you observe that here, if you multiply that minus 2 cos C, this inside the bracket, we get minus 4 sin A into sin B into cos C, so plus 1. So if you observe that, the right hand side is, we have writing 1 in the beginning, 1 minus 4 sin A into sin B into cos C, so which is only the RHS here, cos 2A plus cos 2B minus cos 2C is equal to, we have to prove that 1 minus 4 sin A sin B cos C. So we also get here 1 minus 4 sin A sin B cos C, so which is equal to RHS. So therefore we can write that LHS is equal to RHS. So like this we can prove the given problem.